Good morning, everybody. Anyone, please unmute and tell me the screen is visible.
Yes, sir.
Okay. Yesterday, we discussed about using slip gauges, how to build the slip gauges using M87 set and M112 set. So, in this problem, say all of you observe here, build the following dimensions using M87 set of slip gauge block. So here M87 means it's the metric system and the number of pieces available in that box is 87. See, the first dimension is 49.3825. For this, how do you build the slip gauges? Say, just observe here, all of you. This is the slip gauge block of M112 set. In the same way, you have M87 also. See, these are the slip gauges. The length is 30 millimeter and width is 10 millimeter and the thickness is the dimension. So for building of this dimension, start from last decimal place, that is 1.005. That is the third decimal place. Next come to the, this is the fourth decimal place, and next you set the slip gauge for third decimal place and first and second decimal place. Here in M87 set 1.005, 1.002 and 1.38 is available. So first work is to select the fourth decimal place, third decimal place and first and second decimal place. After completion of this, then come to the unique number. Say here you have 6 is available, then you can go for the whole number, that is 40. So if you add all those things, you will get the dimension 49.3825. So many question paper, you have the same problem, same dimension. Till today, they are repeating the same dimension. So all of you, please write down the problem. Build the following dimensions using M87 set of slip gauge blocks. First, write down 49.3825 millimeter. So end of this online classes, I will give you the entire notes in PDF format. So next come to the point, how do you build the 87.3825? So first, select the fourth decimal place 1.005. Next, third decimal place 1.001. First and second decimal place 1.32. Next, the whole number 4 and the unique number 80. So in the set of slip gauge block, all the dimensions slip gauges are available. How do you set the slip gauges? That's the very important. So now observe here, combination of slip gauges 8. Start from right to left, 1.005, 1.001, 1.32, 4 and 80. So if you combine all the slip gauges, you will get the dimension 87.25. So if it's 87.3215 millimeter. Like this, you can set the slip gauges or build the slip gauges using M112 or M87 set of slip gauge blocks. Next, you come to the point. Say in this problem, all of you go through the problem. Build up a length of 35.4875 millimeter using M112 set of slip gauge blocks used to protector slips of 2.5 millimeter each. All of you observe this diagram. The in between the two protector slip gauges, all the dimensions are set. Observe here. 2.51 slip gauge. It is called protector slip gauges. This is used for in order to avoid the main slip gauges. Say if you use ringing phenomena or while using the slip gauges, if anything happens to the surface, then there may be a problem on the surface. You will not get ringing effect. So for that reason, in this problem, they used two protector slip gauges, safety slip gauges on either side. So in this problem, you directly deduct 2.5 in the 2.5 into 2 or 2 times 2.5. All of observe here, combination of slip gauges 2.5 here and 2.5 here. So after ringing the 2.5 slip gauges in the end of the combination of slip gauges, first see that in M112 set of slip gauges, 1.0005 is available. So this is available. So you have selected fourth decimal place value. Next come to the point, third decimal place, that is 7, 1.007, third decimal place. Next come to the point, first and second decimal place, 1.48 is available. Then you go for 2, unique number 2. 2 is available. Next set the whole number 25. Whole number 25. So if you combine together 2.5 into 2, 1.005, 1.007, 1.48, 2 and 25, that will give you the dimension 35.4875. So all of you, please write down the problem. Build up a length of 35.4875 millimeter using M112 set of slip gauge blocks. And next, continue the problem. In this problem, they used two protector slip gauges. So for that reason, write down, use two protector slips gauge of 2.5 millimeter each. 2.5 millimeter each. So you use two protector slip gauges in the starting, in the end, so that you can avoid the wear and tear damage on the surface of the slip gauges. Next, come to the point, very, very important, angular measurement. Angular measurement. The first definition of the angle. How do you define the angle? Angle is defined as the opening between the two lines which meet at a point. Which meet at a point. So all of you, first to draw the circle, show the line OA and OB. The angle is theta. Angle is theta. This is the angle. The definition of the angle is defined as the opening between the two lines. Here, two lines are OA and OB. And the angle is AOB. And the angle, subtended angle is theta. This is the definition of angle. This is the definition of angle. Next, the circle is divided into 360 parts. The circle is divided into 360 parts. All of you, please listen carefully. Write your name and USN in the chat box. Please, all of you, write your name and USN in the chat box. See, the circle is divided into 360 parts, and each part is called degree. Is called degree. To the power, if you mention 0 or O, that is called degree. If you write any number on the power, if you mention 0 or O, that is called degree. That is called degree. Each degree is divided into 60 parts. Each degree, remember, each degree is divided into 60 parts. That is minute. That is minute. If you put a single dash, that is minute. If you put a single dash, that is minute. And each minute further divided into 60 seconds. If you put two dashes on the power, it is called second. It is called second. Each minute is divided into 60 seconds. 60 seconds. Then radian. All of you already studied radian in PUC as well as in the mathematics. Radian is defined as arc of the circle, angle subtended by an arc of the circle. The length is equal to the radius. Radian means, remember all of you, the unit radian is defined as angle subtended by an arc of the circle. Arc here is AB. Arc here is AB equal to radius OA. Then the angle Q equal to 1 radian. 1 radian. Say once again, the circle is divided into 0 on the number, on the power, that is called degree. And each degree is divided into 60 minutes. And each minute is divided that is called seconds, and that is radian. That is radian. Next, come to the point, the sine bar. Say, all of you know that the angle, how do you measure the angle of the tapered component? What is the taper? One end is higher angle, other end is lower angle, that is connected by a line like this. That is called taper. That is called taper. So you can measure the taper by using sine bar. So this is the slip gauges. This is the slip gauges set for the measurement of taper. This is sine bar. Next, come to the point. All of you observe here. I told you about the taper of the workpiece. One line, the one side is parallel, other side is tapered. See, what is the definition of taper? Taper is equal to half taper angle equal to tan alpha equal to opposite side by hypotenuse. Opposite side by hypotenuse. The taper is defined as T minus D divided by 2L. But in this case, first you measure the taper of the workpiece by using vernier bevel protector. Say, measure the taper of the component using vernier bevel protector or universal bevel protector. From this, you can measure the angle of the workpiece, tapered workpiece, then note down the taper angle. So you have to measure the taper using sine bar. First, keep the sine bar on the surface plate. If you already measured the taper using bevel, universal bevel protector, using that protector, calculate the slip gauges and place the slip gauges, combination of slip gauges like this below the sine bar, and keep the workpiece on the sine bar, clamp it by using magnetic clamp, and you have a dial indicator. Move the dial indicator from one point to the other point. The deflection is 0. The deflection is 0. And the taper angle you have calculated from the reading using universal bevel protector, that is sine theta or tan alpha equal to opposite side by hypotenuse. The opposite, you know that, hypotenuse also you know that. From that you can calculate the taper of the workpiece. All of you understand this problem, this experiment in the workshop, in the metrology lab, while measuring the taper of the given component. You have this experiment in the metrology lab. You have to calculate the taper. So place the tapered component on the sine bar and move the dial indicator right to left, left to right. If the deflection of the dial in the dial indicator, which is less than 30 divisions, so you will not get 0, you will get 30 divisions. If it is less than 30 divisions, then whichever the slip gauges you have calculated by using universal bevel protector, that is correct. So like this, you can calculate the taper of the workpiece by using sine bar. Next, come to the point. One more experiment. Say this is the checking unknown angles of the heavy component. So this is the heavy component. Say casting, place it on the floor and keep the sine bar inverted direction, and using that dial gauge, see that the angle which is available in the dial gauge, that is the angle of the component. Say here the height, the difference in height, you substitute in the equation tan alpha equal to opposite side by hypotenuse. These two are vernier height gauges. Here dial gauge is set on the vernier height gauge, which makes the contact of the roller of the sine bar on the component, that will give you the opposite side by hypotenuse. Tan alpha equal to opposite side by hypotenuse. Then alpha equal to tan inverse opposite side by hypotenuse. That will give you the angle of the component. Next, come to the point. This is the sine center. This is very, very important for mechanical engineers. Sine center. So here you have to use theta equal to sine inverse h, height, divided by L. Then you can calculate the angle of the tapered component. Before that, the definition of taper component. Say one is large diameter, other one is smaller diameter. That is L, D minus D. This is uppercase letter D and this is lowercase letter d. And the taper is, definition of the taper is D minus D divided by 2L. All of you observe here. This is the L for calculation of taper of the component. This is the L and this is the D and this is lowercase d. Taper equal to D minus D divided by 2L. But in case of science center, the distance between the two anvil points, that is the clamp, that is the L. So that is L and this is the half taper angle. The same procedure, place the taper in between the two centers of the science center. By these two centers are spring loaded. Just pull this lever backside and both the levers pull backside and keep the taper in between the two centers. And before conducting this experiment, calculate the height h of the slip. Measure the taper of the component by using universal bevel protector. Calculate the taper or note down the taper, approximate angle of the taper. Approximate angle of the taper by using universal bevel protector and calculate the height. How do you calculate? For this, you have the equation theta equal to tan inverse of h divided by L. So you know the L, this is standard. Calculate the h, place it below the roller and then move the dial gauge on the taper component on the surface plate from one end of the taper to the other end. The deflection is 30. Say you have this experiment in the laboratory. You have to conduct the experiment on tapered component. Then the deflection of the dial indicator is 30. But actually you must get a 0. But due to the human error, you will not get 30. You will get 30 deflections. If it is less than 30, that is very good result. If it is 30, then no problem. Move the dial indicator from left to right and right to left and see that the deflection is less than 30. Then the calculated the slip gauge's height is correct. Slip gauge's height is correct. Then calculate the half taper angle tan alpha equal to D minus D divided by 2L. So that will give you the half taper angle. And this theta is required for calculation of the slip gauges, to build the slip gauges for calculation purpose. That is theta equal to sine inverse h divided by L. H divided by L. Then this is the vernier bevel protector. You have to use this universal bevel protector for measurement of taper in the metrology laboratory. And next come to the point, all of you already discussed about the slip gauges. In the same way, angle gauges are also available. All of you observe here the shape and size or different sizes are available. This is the working surface and this is the included angle and this is the theta. The angle is the theta. Different angle, different pieces are available here. Use the different pieces for measurement of angle. Next, come to the point. Say Tomlinson was developed the angle gauges in 1939 and the 75 millimeter length and 16 millimeter wide. All of you observe here the 75 millimeter length and 16 millimeter wide. And next come to the point, the different slip gauge, so different angle gauges available in the box is 1 degree, 3 degrees, 9 degrees, 21.7 degrees, 41 degrees. And also the minutes available 1, 3, 9, 27. And the seconds, if you divide the minute in 60 times, the seconds are available 3, 6, 18, 30. So you can use different angle gauges for combination of angle. From that you can calculate the angle. See, in this box 13 pieces are available. Remember, you may have the question in Viva was how many pieces available in the angle edges is 13, 1, 3, 1, 3. This is the working surface. The length is 75 millimeter and width is 60 millimeter, 75 and 60. And number of pieces and different sizes. All of you go through this table and use this particular number for the measurement of angle. Let's come to the point, that is the different problems we have here. You set the angle 57 degree, 34 minutes and 9 seconds. How do you set the angle gauges? Say here, first set the 41, then 27 and keep the 9 degree angle block in the reverse direction. Then add 1 degree and again deduct 3 degrees in the reverse direction. That makes you 57 degrees. That makes you the 57 degrees. Then set the minutes. First select your 27 minutes and add 9 minutes and put the 3 minutes in the reverse direction, which deduct the value from these two values. Then add 1, then it becomes 34 minutes. Then it becomes 34 minutes. Next point is the setting of seconds. First you select the 6 seconds plus 3 seconds, that will give you 9 seconds. Then first you have set 57 degrees, 34 minutes and 9 seconds. You understand while conducting this experiment, but unfortunately you don't have setting of angle gauges in the laboratory, only problem, only theory. Next, come to the point, the autocollimator. Autocollimator. Say, if you observe here, in autocollimator, light source and the lens and the component. This is particularly used for measurement of straightness of the component. Remember, autocollimator is used for the measurement of straightness of the component. Straightness of the component. This is the principle of operation of autocollimator. Principle of operation of autocollimator. First, switch on the lamp. Switch on the lamp. Here you have a diffuser and you have a cross line. Cross line means a plus mark. Plus, you have a plus mark on the gratitude. On the gratitude, which the light rays come and hit the beam splitter. Beam splitter. From this beam splitter, the light rays are passes through the objective lens and fall on the component. Fall on the component. Once again, the principle of operation. First, switch on the lamp. Light rays fall on the diffuser. Then the gratitude. Gratitude has a cross line, plus mark. Then the light rays hit the beam splitter. Then from the beam splitter, passes through the objective line and fall on the workpiece. Fall on the workpiece. After falling on the workpiece, the reflected ray, remember, again, the line, observe here, this is the reflected ray. Reflected ray, again, which is coming to the measuring graticule. All of you here, observe here, the arrow mark coming to the measured graticule. Again, in the measured graticule, you have a cross mark or plus line, then which you fall on the eyepiece lens, and you are observing here. This is the principle of operation of the autocollimator. So this is as it is, workpiece is placed vertically on the table, Then just tilt the workpiece. All of you observe here, the dotted line, dashed line indicates the angle theta, tilting of the workpiece, angle theta. Then this cross-line graticule fall on the objective lines, reflects back and passes here and passes through the measured graticule. And then if you observe through the eyepiece, there will be deflection or the distance between the crosswire of the graticule and the measured graticule, that indicates the angle theta, inclination of the angle theta. This is the principle of operation of the autocollimator. Principle of operation of the autocollimator. All of you, please write down the question. All of you, please write down the question. Explain briefly. Explain briefly with a neat sketch. Neat sketch. Principle of operation of autocollimator. Principle of operation of autocollimator. Question mark, put a question mark. Then write down least applications, and limitations. And all of you observe here, one more experiment or one more test by using autocollimator. Using autocollimator, you can measure the straightness of the component in a particular distance. You can divide the distance A, B, C, D like this, and how much difference of straightness is present on the component, that is, you can measure by using autocollimator. Straightness can be measured by using autocollimator. The first you divide the straightness into number of parts and set the autocollimator at a particular distance, that is point A, B, C, D like this up to J. Then see that how much difference is present in the straightness with the bottom line, that you can measure by using auto collimator. By using auto collimator. By using auto collimator. So this completes module 1. This completes module 1. This completes module 1. And now you can unmute yourself. Unmute yourself. Hello. Please unmute yourself.
Yes, sir.
Say in module 1, starting from line standard, end standard, till today, the autocollimator and the straightness measurement and the angle measurement. So if you have any doubt regarding starting from line standard to today's class autocollimator, you can ask now. Please, all of you unmute yourself and ask me the question. If you have any doubt, hello, unmute yourself.
No doubt, sir.
No doubt. And today I will share the notes, complete module 1 notes. And all of you download that, or you can take the printout. Okay. Hello. Hello. Renil.
Yes, sir.
You can download the notes, take the printout, or you can directly use it from the mobile. So each and every point which is required for the examination, that is available in the notes. And one thing, all of you, please collect 4 previous question paper. Previous question paper. And see that which are the ಹಲೋ ಹಲೋ ಕೇಳಿಸ್ತಾ ಇಲ್ವಮ್ಮ all of you please collect previous 4 question paper and group the questions according to the module and see that in the notes all the material is available. Suppose if you don't get any material, immediately you contact me, I will give you the notes. According to my view, in PDF notes which I made here, in that you will get all the material which is required for the examination in module 1. So suppose if you don't have any material, then you contact me, I will give you the material. Okay. Okay. Thank you very much. And now I stop this class and I will continue in the next class. Tomorrow I will continue the next class.